Hello and welcome back to Lesson 10. This is part 2. And the next example we're going to do is, for lack of a better name, is a step-by-step example of a more elaborate network than we've looked at so far. We have a tank that has an initial level or initial depth of 10 feet. The tank bottom is located at 400 feet and the tank is 50 foot in diameter and it's up to 20 feet high. That tank is connected by this pipe 1 that's 50 feet long that supplies water to a node that is located at elevation 0. So it doesn't take a genius to figure out the 400 feet to 0 feet is more than 50, so we will use the pipe characteristic given here, but just bear in mind that the tank has additional piping to handle the 400-foot elevation drop. That's the best way I can state that. So here's the network layout and the pipes that are labeled, and here's the pipe characteristics, and then the first thing we'll do is we'll clip out this part of the picture because that's all we need. And then we have the various demands are shown in this diagram. We'll clip out that and use that to establish the demands. So on the class website, again, oops, made a mistake. The example files are contained here, and this is called example 4. And there's a node layout and then the step-by-step. So I'm going to grab those two bitmaps and download them so I can run them live. On the off chance I make a mistake on video and can't correct it, the various examples are here already. So let's grab the 3 BMPs. Right click, save target as, desktop, my playhouse, it's 1, right click, save target as, and right click, save target as. Alright, so that's all we need. Let's go ahead and create a new project. So choose File New. We won't save that one. And let's first pull in our backdrop. So it's example 4, step-by-step, node layout, step-by-step, pipe data. Let's start with node layout. And we will lay out the nodes. So there's node 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. Our reservoir. And we'll go through and start parameterizing the nodes. So node 1 has a demand of 0.15. Node 2 has a demand of 0.18. Node 3 has a demand of 0.13. Node 4 has a demand of 0.21. Node 5 has a demand of 0.31. Node 6 has a demand of 0.02. Node 7 has a demand of 0.05. Node 8 has a demand of 0.08. Node 9 has a demand of 0.51. Node 10 has a demand of 0.18. Node 11 has a demand of 0.61. Node 12 has a demand of 0.02. Node 13 has a demand of 0.17. Node 14 has a demand of 0.71. Node 15 has a demand of 0.11, node 16 is 0.05, and node 17 0.51. All elevations are set to 0. We can try to take care of our reservoir elevation. Oh, it's a tank actually, my bad. We will delete the reservoir and we'll actually put in the tank info. So the tank has an elevation of 400 feet is what we're told. The initial level was 10, the maximum level was 20, and the diameter is 50. So there's our tank, and then our nodes. We know that the tank should supply all the demands, so we don't actually have to explicitly supply this for. Let's turn off that backdrop, and that's all we have so far. Let's now load in the pipe network, and it's going to be close, so it will allow us to at least draw the pipes in the correct number order. So pipe 1 goes from the tank to that node, pipe 2, pipe 3, pipe 4, pipe 5, pipe 6, pipe 7, pipe 8, pipe 9, pipe 10, pipe 11, pipe 12, pipe 13, pipe 14, pipe 15, pipe 16, pipe 17, pipe 18, pipe 19, pipe 20, pipe 21. Until we have pipe data, we can't do much, but I saved a bitmap that had the individual pipe data. So the upper length is, the upper rows is the length, and the lower is in the diameter. Most of them, except for pipe 14, are 50 footers. So let's take advantage of the group hug tool. So what I did is I used this polygon, and I was left clicking to hit the vertices, and I right click to close it. Now if I go to edit, group edit, I want to change all pipes, and I want to replace the one thing I can't replace is the length. Oh, that's cute. Okay, never mind. We'll have to do that by hand. Now, I'll put the diameter at 8 for the time being, and then we'll fix it from pipe to pipe. So pipe 1 is a 50 footer. 50, 50, 14 is my 100 foot length. And it's a 10 inch, so while I'm here I'll fix that. Okay, pipe 15, everything else is a 50. 50, 50, 50, 50, and 50. Now we have to go back and deal with the diameters. So pipe 21 we just did is a 10 inch. Pipe 20 is a 10 inch. Pipe 18 is a 10 inch. Pipe 19 is an 8 inch, no change there. Pipe 16 is a 12 inch. Pipe 17 is a 12 inch. Pipe 15 is a 12 inch. Pipe 14 is a 10 inch. Pipe 13 is a 12 inch. Pipe 12 is an 8. Pipe 11 is an 8. Pipe 10 is an 8. Pipe 9 is a 12 inch. Pipe 8 is 8. Pipe 7 is 8. Pipe 6 is 8. Pipe 5 is 8. Pipe 4 is a 12. Pipe 3, 8. Pipe 2, 8. And pipe 1, 12. So now all the diameters are set. Let's return to the presentation and the actual problem statement, because it tells us that the Hazen-Williams coefficient is 100, so we'll use that. We can do that with the group edit term, edit, group edit. We want to take pipes, we want to take roughness, and we want to put 100. It's done. Yes, I know it was already 100, but that's how you use the group editor. So we have demand specified, we have pipe diameter specified, we have pipe roughness specified. We do need to make a quick check on one thing. I forget if the demands are in cubic feet per second. Okay, so we need to change our flow. Right here it's in gallons per minute, so let's change it into cubic feet per second. And we have Hazen-Williams is the correct loss model to use. Unload the backdrop, and there's our pipe network, and now we have to run it. We are successful. We can turn on our flow arrows. And we have the flows. We can have it applied pressure and flow. We can turn on the notation. A little hard to see because I made the numbers big, but the numbers with fractional components next to the nodes represent pressures. The numbers with fractional components next to the pipe represent flow rates, and then the solid integer numbers are the pipe ID or node ID. Notice it says this tank is tank 18. If we don't like that, we can call it tank U. And change our notation as necessary. So that completes example number 4.